All right, guys. Thanks again for joining the webinar today. So again, my name is Sebastian. I have my colleague Gareth with me. So today we're going to be conducting this webinar about the smart meter. So there will be a basic side of things, but also an advanced side of things. One thing that I will ask you, if you can just keep your question at the end. So we're going to have a question session. Then you can just go full on us and just ask all the questions that you have. So let's get slides going here. All right. So here you can see a picture of myself and my colleague. If we haven't met before, again, I always recommend people to come at All Energy this year, which is a big convention in Melbourne. So you can meet the team and meet in person. So the agenda today is talk a bit about the meter especially and some challenges that installers are having, but there's tips and tricks where we can help you in general with the setup. Just let's say good practice. So just to give a rundown of what Fronius does, so we don't only do solar inverters, we do also battery charging and welding machines. So we have actually three different business units. So the perfect charging was started in 1945. Then 5 years down the track, we moved to welding. And finally, in the renewable sector, which is the one where we manufacture the inverters in 1992. So today what we're going to talk about, of course, is the solar energy sector, which is where we manufacture inverters, but also where we also sell smart meters. So smart meters are quite important. It's really good to have an inverter which can show you how much your system is producing, but it is important to also have a meter to be able to see how much you're consuming, let's say on site. So why do you need the Fronius Smart Meter? As mentioned before, the importance is basically to see what's happening on site, so how much you're consuming, but also to future-proof the system. What does this future-proof mean? Is if you install a Fronius inverter and a Fronius Smart Meter, you will be able to basically see your site consumption. And then from there, you will be able to define some loads. And when you define some loads, you can do some energy management. So turning on and off different devices, depending on your excess of energy, for example. You can also going to be able to size batteries also with all those information that you basically got from this Fronius Smart Meter. So that's how we future-proof the system by having this Fronius Smart Meter. So as mentioned before, we're going to also have some new features coming on SolarWeb. So all the system who already has a smart meter installed, you will be able to run some simulation. So this is just an example. It's not out yet. We are planning to have that released hopefully end of this year. And again, no exact dates, but you will be able to run, for example, a power diverter or storage simulation. So you can see what happened before you install the product and what happened after you install the product. So that's where there's going to be a possibility of you going back to the customer saying, hey, I think it's time for you to install a battery or a power diverter. So let's now go into the technical details of the meter itself. So we have different types of meters for different type of jobs. So let's start with a single phase. We have two versions. So we have the 63 amps direct connect, which means that it is in series with all your loads and the grid. And we also have a city version, which is basically the 240 UL meter. So again, the 63 amp single phase, the name tells you that if your main switch is rated at 63 amps, you can use this one, or else you need to use the 240 UL meter, which uses 333 millivolt CTs on the CT side. So I will cover a bit more about this 240 because we also have a three-phase version of this meter. One thing to remember is the 240 UL meter, you can use that on a single phase installation here in Australia. And the 63 amps also will be single phase application. Now let's look at the three phase application of our Fronius Smart Meter. So basically you still have a direct connect, which is rated at 63 amps. So you can have two phase or three phase topology, and it's again WYE connection. And this basically requires a 120 degrees phase shift. So basically phase to phase you have 415 volt there. Then for your commercial jobs and also some resi jobs, you have a 50K smart meter. So this one is basically DIN rail mounted, same as the previous one explained, but those one needs CTs there. So what CT do you need to buy? It's really simple. It's whatever the main switch is rated at to 5 amps. It's always to 5 amps. Then from there, we're going to show you later on how to commission this meter. Again, this one can be connected to a two-phase or three-phase topology. And again, phase to phase, it's 415 volts with a 120 degree phase shift. Then we have a 480 UL meter. You can see that it looks the same as the single phase one. It's just that it's a bit different application here. So for this particular 480 UL meter, you can use that on a two-phase or three-phase property. And in Australia, I'm pretty sure some of you will know, you have the split phase, so 480 volt phase to phase. So that's where you need to use this particular one. If you try to use, for example, a 50K smart meter on a split phase, it won't actually work. So you need to make sure you use the 480 UL meter. This meter can be used for a three phase also if you want, and the CT is basically whatever the main switch is rated at to 333 millivolt. I personally recommend to use the 480 UL meter, but maybe that will be a question at the end for you guys, where maybe I will ask you which one you actually prefer to use. So CTs, what type of CTs you can use with our Fronius Smart Meter? You can use ROGOWSKI coil, you can use split CTs or regular CTs, which is basically solid coil CTs there. So the ROGOWSKI coil, if you guys are installing any of them, I would highly recommend get in touch with us, because you need to make sure that the one that you're buying has a DC adapter with it. So highly recommend to get in touch with the application engineers to give you some models. Then you have your split core CT. So it was one of the, I would say, the standard one that people uses. It's basically easier for people to basically clamp it around the, let's say, the cables on site. All right, now comes the interesting part of the installation on the meter. So it's really important to know where to put it and what settings you need to set on the smart meter when you activate it. Sorry. So basically what happened is we have two settings on the Fronius Smart Meter. So you have one which is called feed-in point. You can see it on the top left-hand corner, but also you have a consumption path. So depending on where you're installing the meter, basically you will need to set up these settings, which is feed-in point or consumption. If you install the Fronius Smart Meter, basically after the main switch of the property, and on the other side you have the inverter and all the loads, we call that feed-in point. And the actual calculation is really simple. We have a monitoring card inside the inverter. The Fronius Smart Meter monitors how much goes to the grid. The card inside the inverter monitors how much is generated. The difference goes to the load. So you can see the calculation there. So from there, this is one of the most common, or is the most common one in Australia. I highly recommend people to just remember this one. This is the most important for sure. Then you have another setting, so another location that you can put the Fronius Smart Meter, which we call the consumption path. So what happened is on one side of the Fronius Smart Meter, you should see the inverter and the grid, and on the other side, you should see all the loads. Then the calculation is really simple. The meter measures the consumption on site, and then when we know how much power is generated from the inverter, the difference is basically whatever goes to the grid or is harvested from the grid. From our experience, what we see is people basically install the meter in this location, and instead of selecting feed-in point, they select consumption, because they said, hey, I'm measuring consumption, I need to select consumption, but it's not like that. So this is one of the tips and tricks there. The distance also between the Fronius Smart Meter and the inverter is 300 meters. So this is for the RS485 communication, what you will need to do between the meter and the inverter. So I will cover that a bit later. So let's look at the schematic of the whole setup now. So that's how our 63 amp and three-phase 63 amp smart meter looks like. So here you can see the L in and L out. So it is in series, but it needs to be connected. In the past, we've seen some installers where they go L in here, and then we connected also a few load sides on this side, on the L in, and this result in an incorrect display of power flow on our portal. Also, at the top, it's really important to remember the connection 33, 34, and 35. This is basically the MODBUS communication. So basically the cable that you need to connect from here to the inverter. So you will also need to make sure that on both in smart meter, between D positive and D negative, you install this 120 ohm external resistor. Usually there will be a sticky tape and the resistor on the side of the meter out of the box. If you lose it or it wasn't in the box, the easiest thing to do is just go to JCar and just get like a 120 ohm resistor. So this is basically the connection between the Fronius Smart Meter and the inverter. So again, you just go from D positive, D negative, and ground to the D positive, D negative, and ground of the meter. So it's quite straightforward. So you can see it here. This is D positive, D negative, and ground of a meter. You just match it on the data manager card of the inverter. Also, so basically those 120 ohm resistor, you need to terminate the loop on both ends, so at the meter and at the inverter. So if you look inside, so we're going to have a video to show you guys how it is, where the antenna of the data manager card is. If you unscrew that, you will see a small switch at the top. So this is basically turning on and off this resistor. And usually from factory, this is already on, so I wouldn't be too worried about this particular component there. So this is then one of a schematic for the 480 UL meter. This one uses CTs, so it's a bit different from the direct connect. One additional connection that you will need to do is the CT connection to the meter. So one thing that we want to make sure is that installers look at the CT manufacturer installation guide and look where S1 and S2, so basically the primary and the secondary, needs to be connected with the meter. Then the MODBUS communication stays the same from the data manager card to the meter. So you just need to make sure that you match D positive, D negative, and negative there. Then the rest is the same. Yeah, it's quite straightforward. What we see sometimes is that the CTs are clamped around the wrong phase, so they have a wrong voltage reference. From there is, let's say, incorrect value showing up on SolarWeb. So just make sure that you clamp the CTs around the right phase. So you have CT1, CT2, CT3, and then you have L1, L2, L3. So just make them match. Then we have a same for a Fronius 50K smart meter, but again, remember, those one are different CTs. So those one are whatever the main switch is rated at to 5 amps. And again, you will have your connection at the top for your S1, S2, and you just need to make sure that it is connected properly and that the CTs are facing the right direction. And from experience here, it really depends on the manufacturer. Sometimes two manufacturers can basically say the opposite things on their CTs. So that's quite, I would say, important there. Again, on the top right hand side, you will then need to do the data communication between the meter itself and the data manager card. So again, you need to make sure that D positive, D negative, and negative are basically connected to the positive, negative, and ground on this one. All right, so now let's go to the setup of the meter. So you guys know how to basically install or where to install the meter. You know what type of meter we have. So let's now set up the meters. So it's quite straightforward. What I usually recommend in installers is to put the system online. And when this part is done, what they do is connect their phone to the inverter or whatever device they are using, type the IP address 192.168.250.181, and then this page will show up. From there, what they need to do is just click on password, then they need to set up a service password, and then after that, they go to the meter. When they go to the meter, this is what it will look like. We will need to select the Fronius Smart Meter and then select feeding point. If the meter is basically set at feeding point, which means one side the grid, the other side is the inverter and all the loads. From there, press the tick and just wait for the meter to activate. For the 480 UL meter, it's a bit different, because remember you have CTs for this one, and also the activation page will look a bit different. So here you see this is for a 480 UL meter. It's the same process, same tab. Then from here you select the Fronius Smart Meter. Then you will have more options. So you select feeding point here, and then you will need to put the primary side of a CT. So if it is 100 amp, you put 100 amp there. If it is 1000 amp, you put 1000 amp. And then the meter will do their own ratio inside. And of course, you need to select your grid type to here. For the for the 50K smart meter, this is a bit different. So the activation of the 50K smart meter is the same as the first few slides that I showed you. So it's different from the 480 UL meter. The ratio of this particular one, you will need to enter it on the screen of or on the actual meter where you have P and forward on just next to the screen. So what you will need to do is go in front of the Fronius Smart Meter, press P and forward together, then it will ask you a code, and from factory the code is 0001. When you press P and forward together, you will go to CT, and this is where you need to put the ratio. So for example, let's say you have a CT which is rated from 100 amp to 5 amp. So basically you need to do 100 divided by 5, which is 20. Then you need to put 0020. When you're done with that, press P and forward. You will see VT. Don't change anything. And then press P and forward to enter the password. So I recommend just leave the password as it is, 0001, so that if anyone needs to come back, we know that it is the right password. In regards to the VT, you can do also on the transformer size. So when you're when you have high voltage, for example, and you get CTs to measure basically high voltage to low voltage, so you can do that also with this particular meter. In Australia, I would say only few customers has done something like that. Anything in regards to VTs, please get in touch with us, and from there we can give you some advice of how to set that up. So now my colleague Gareth will talk a bit about the zero export limit.
Hi everybody. So zero export is one of the most common functions you might be doing with the Fronius Smart Meter other than regular monitoring. So if you have a DNSP who doesn't want you to export, so an example for how that might work is you might have the, your Fronius inverter here, and you've got your smart meter at the feed-in point. It has to be in the feed-in point. It can't be in the consumption path like the diagram Sebastian was showing before. You have your pool pump and your loads, and say it's a 5 kilowatt inverter, so the pool pump's using 2 kilowatts, the loads are 3 kilowatts, so there would be no export in that scenario. But if you were to turn the pool pump off and maybe your loads went down to 2 kilowatts, there'd then be 3 kilowatts going through the smart meter. The smart meter is going to see that, and it's going to send a signal to the inverter to drop its output down to 2 kilowatts to achieve that zero export. The way that you set this up is that you go into the IP address, as Sebastian was talking before. You need to activate the Wi-Fi hotspot to use that IP address 192.168.250.181. Enter your service password, and you go to DNO editor. And then you're going to go to dynamic power reduction. This is assuming you have already set up the meter. In dynamic power reduction, you'll see that we have a couple of options here. We want limit for the entire system. And there's two options here: total DC power of the system and max production power of the entire system. And there's two options there, which are you can set it by wattage or percentage. If you're doing it by percentage, then you need to have this middle line here, total DC power of the system, filled out correctly, and then you would put a percentage in. But I would recommend, that's for Europe, where they have certain DNSPs who ask them to do it by percentage. I would recommend you don't use that function and you just do it by wattage. So we're going to change that to watts, and then we're going to put max power production of the entire system to 0, and that's going to give us a 0 export. Back over to Sebastian about the data manager box.
So yeah, so we spoke, thanks for that, Gareth, explaining how to set the 0 export there. So in Australia, a lot of, let's say, installers also uses this combination with the Fronius Smart Meter and the data manager card to do the export limit. So as we explained before, the Fronius Smart Meter needs to be connected to a data manager card, but you can also connect it to a data manager box. So what is a Fronius data manager box? Basically, it's a card. It's a Fronius data manager card, but we put that in a box, and it doesn't need to be connected directly to an inverter. So what happened is some installers want to, let's say, provide the next level of service to some of their customers. We said, okay, we're not sure what's our consumption. It varies so much that we don't have data. So then the installer, what he will do, he will go inside, install a Fronius Smart Meter, then install a data manager box, monitor the system for a few months, and then size the system accordingly, because he will see what the site is consuming for several months. So this was one of, let's say, the usage of this data manager box. So from there, that's what you can actually see, just consumption on our monitoring portal, and you can see how much power they're using from the grid. But the thing is, there's also another usage of this Fronius data manager box. What happened is some installers or some customers already have third-party inverters, and they want to see how much those inverters are producing. So what you can actually do is install one Fronius Smart Meter in the main switchboard, and you select feeding point, and then you go and install another Fronius Smart Meter just after the third-party inverter and connect a data manager box to it. From there, you will have an ID for the box, an ID for the inverter, our Fronius inverter. You just put that under the same account on SolarWeb. From there, you will see the right bubble view on our portal. The second thing that where people uses a data manager box is, for example, you have a commercial job where you're installing the inverter is really far from your main switchboard, which means you will need to run a long cable from one point to the other one. So the customer doesn't, or the installer doesn't want to do that. What they do is they put an inverter where the PV is, and then they put a Fronius Smart Meter in the main switchboard of the property. Then they connect the Fronius Smart Meter to a data manager box, and then from there we have a monitoring card which is inside the inverter. We put both of them online. We have two data logger IDs, so two IDs for each device. We put it under the same SolarWeb account. From there you will see the right flow. In this setup, unfortunately, you can't do export limit. It's just monitoring purposes so that you see the right energy flow. And that's how it looks like on SolarWeb. So you can see at the top there's 240.237.814. This is connected. This is basically the data manager box, which is connected to the Fronius Smart Meter. How do we know that? You can see where it says energy meter. It tells you the meter is connected to 240.237.814, which is the box. And then the SIMOS has the same data log ID, which is basically the second one, 240.293.951. From there, both of them are connected under the same account, and the energy flow will basically look like that. You will see the right energy flow. If you're monitoring a third-party inverter, you will see that the bubble where you have a PV will also increase with the other inverter, for example. But that's basically where people uses the data manager box. The thing now is we know that some customers has already installed a third-party inverter. So what we want with our product is to be able to adapt with different product. So what happened is we have this multi-smart meter features. What this is basically, instead of having boxes and meters everywhere, what we say, okay, you can install the Fronius Smart Meter for, let's say, specific loads in your house, and you can monitor them. From there, you can connect multiple smart meters to one data manager card. You don't need to buy the data manager box, for example, in those situations. So just looking at configuration, you can have up to 4 devices connected to a data manager card. So you can have option 2, which basically have the primary meter, then 3 other smart meters, or you can have one primary smart meter, and let's say a non-pilot and 2 other first smart meters. So always only 4 devices, and a battery also counts as a device. So that's how it looks like. The wiring is really simple. Everything is in series on the Modbus side of things. So you can take from the meter from feeding point to the next one, to the next one, and to the data manager card. It's really up to you. You decide what is in series. So you can go from one point to the other one. So at any, let's say, connection, you need to make sure you have only 2 wires coming in. That's basically the principle of having stuff in series or meters in series. So just looking at the wiring, that's how it looks like. So you can see primary meter here, then consumption meter, generator meter, which is again the Fronius Smart Meter, and the Fronius inverter. So you can see everything is in series there. One important thing is whatever is at the end or at both ends, you need to make sure you have a 120 ohm resistor. Remember, our data manager card has one and it's always on. So if your data manager card is in the middle of a loop, you will need to turn that off and then make sure you have 120 ohm at the start and at the end of a loop. So when you install the meter, so you will also need to do some addressing there. So each meter has different setup. So for example, for the 63 amp single phase, what you will need to do is enter the code 2633. So you need to press a long forward button, then you enter the code 2633, and then you basically see the address there, so AD001. So you need to name this particular meter 002, for example, if it is an addition to the loop. Then from there, for the 63 amp, it's a bit different. You will need to press P and forward together, then enter the code 2633 again. So it's just a different amount of tabs. You will see again ADR when you press P and forward, then you can just change the address. For the 50K also will be different. You press P and forward, so the code is the same, but then through the menu, it's a bit different. You can see that there's more options. So you need to scroll, press P and forward until you see the ADR or address number there. You can, as mentioned before, you can have up to 4 devices. So the primary meter will always need to be 001, then the rest needs to be 02, 03, and 04. Just to show you how it will look like on our monitoring or on the inverter homepage where you activate the meter, you will see primary meter for a smart meter. So this is your first one, and then you can start to add. Then you will need to make sure that you select the location. So in any system, you can have only one at feeding point. The rest needs to be in consumption path. And then from there, you need to select what's the category. So you can say, okay, you're measuring a battery, you're measuring an inverter. So there's quite a lot of options there. And if you want to change the settings, you can change it. Or if you want to delete the meter from the loop, you can also delete it here. So here it shows you the address where you need to activate it. So we have a small video of how to do the connection. So we're going to play that now, where we do all the connections. So basically the one on the left is the meter which will be in the middle, And then on the right hand side is the one which is basically at feeding point, which is basically at the end of the loop. And this is the one which needs to have a resistor there. Here you can see the orange plug, so where you have your DC positive and DC negative. So that's where we do the connection here. Again, DC positive goes DC to DC positive, DC negative goes to DC negative, and negative goes to negative there. So that's why it's quite straightforward. So here you can see all the connection. Then here we're gonna put the address of each meter. So we need to enter the code, press forward to move across, and press P to basically go up and down, and press P and forward to go into the menu or enter the code, for example. So that's what you need to do, press P and forward together. So you see node, press P and forward. So P and forward is basically moving from menu to menu. And then just pressing P means that you want to increase the number. So here we say it is address number 2. Then we just need to finish the whole process by pressing P and forward until it asks us to, to enter a password. Then we just save all the settings. From there, we connect that back to the inverter on one end. And if, let's say, for example, the data manager card doesn't have this resistor on, just turn that on, because in this particular case scenario, the data manager card is basically at the end of the loop. From there, you will be able to activate the Fronius Smart Meter. So this is the primary one, which is feeding point, the Modbus address 1, always number 1. Then the other one that you need to add, you can say, okay, this is the workshop. You can give it any name you want, and you need to say what type of meter it is. So again, it needs to be consumption meter. You can have also generator meter if you have, let's say, a third-party inverter if you want, and then make sure you save the settings there. From there, my colleague now, Gareth, will talk a bit about the RS485 communication there.
Hi, everybody. So RS485 is a serial communication, which means that there's going to be all in a straight line like this and parallel connections for your D positive, your D negative, and your ground. So what that means is you're not going to have star, T-drop, or ring configurations like these ones on the right-hand side. So you can't have offshoots coming off most of the time. There's a few circumstances when you can do that, but in general, just try and remember it's just one straight line without little offshoots or in a ring or anything like that. Otherwise, it can create serious communication problems. As Seb has said, it needs to be terminated at each end. So the start of the loop and the end of the loop needs to have a 120 ohm resistor across the D negative and the D positive. So when we've been talking about putting that resistor into the smart meter or turning that resistor on and off on the inverter, that only applies if you're at the beginning or the end of the loop. If you have a setup where the inverter is in the middle, like any of these ones we've got here with the red lettering, then you would have the switch off, and that switch is behind the aerial as shown in the video before. It can be quite difficult to find, so you might want to have a look at the replay of this later on just to check where that is. I know certainly I took a while to find it when I first started. And again, with the meters, not every meter is going to have that resistor. It's just the meter which is on the end of the chain. In terms of cables that you can use, most people use sort of Cat6 cable, and you need to, when you're going into the meter box, you're going to need to check about voltage, insulation ratings, and things like that. But the main thing to remember about it is that the D positive and the D negative must be a twisted pair. That doesn't mean that you have one twisted pair into the D negative and another twisted pair into the D positive. It means that the D negative and the D positive, we want those to be twisted together and then separate them when we get to the connection point and put them in. And then you need to have an earth so that all of the meters or the connections on the RS485 network share an earth. This is to do with what we call common mode interference. So basically, it's the type of signal is as opposed to older styles of signals, when you're going to have the receiver measuring the difference between the earth and the active, the receiver is measuring the difference between the D positive and the D negative. So there's going to be a voltage differential between the two, and it's going to be measuring the difference between them. The reason this is a good idea is because when you have common mode interference, when we have those cables twisted together like that, if you have some interference which is creating a fluctuation, it's going to affect the positive and the negative equally and in the same direction. And so if you're measuring the difference between the two of them, if they're equally affected, that doesn't affect your signal, and you have less electromagnetic noise within the signal. Now we're going to talk a little bit about MODBUS, TCP or RTU. So you'll hear these phrases bandied about quite a bit, but it's often not obvious to people what they are. MODBUS RTU is a form of MODBUS which is delivered over RS485, which is this cable that we're just describing. MODBUS TCP is an Ethernet packet, so that's used over, a LAN or over the internet or that type of network. So the difference between the two of them is that in Modbus TCP, you have an IP at the front of the address, and you have TCP, and this section in the middle here is where the actual substance of the Modbus communication is. Over RTU, it has exactly the same substance and body, but it has a different addressing system because it's over a different protocol. Now we're going to switch over to supply partners, and they're going to give you a little information about some of their products. So I'm just going to mute ours, and you guys are going to unmute yours.
Thanks, Gareth. It's Andrew here from Supply Partners. I work here in the technical team alongside Dane Muldoon and Andrew Simpson. Today we're going to be talking about wireless solutions from between the smart meter and the primary inverter. So we can go to the next slide if we can. Yep. Fronius's smart meter range makes it easy for installers to offer end users high quality site monitoring data, along with support for export limitation when required. Also mandatory if you're putting in a Fronius hybrid, the battery needs to know when to charge and discharge. All of Fronius's smart meters connect to the inverter via RS485, as Gareth has shown you previously. Running a physical RS485 cable is always recommended if possible. Now, for short runs, installing an RS485 cable is pretty straightforward, but over longer distances, or if there are obstructions, running a hardwire cable can be problematic or even sometimes impossible. The classic example of this is a rural property. You've got the main switchboard out at the front, then you've got a feed going to the shed, a feed going to a house. Customer insists they want solar on the shed, they don't want it on the roof of the house, it's ugly. So you're going to have to install the energy meter remote from the inverter. Now, that could mean having to dig a trench, which is going to be very expensive and time consuming in a lot of instances. Sometimes it's just not feasible physically or financially. So supply partners offer RS485 meter link kits to solve these problems. Now, what that does is it transparently converts the RS485 link at the meter into a Wi-Fi signal. It beams it across to a second device located at the inverter that turns the Wi-Fi signal back to RS485. Now, neither the meter or the inverter even know this is happening. As far as they're concerned, it's still just a hardwired cable. As far as the meter and inverter are concerned, it's entirely over a physical cable, even though you've got the wireless devices in between. Now, this wireless RS485 meter link kit will only work from the smart meter to the primary inverter. The solution cannot be used for inter-inverter communication, as it isn't done via RS485 at this time. You will still need to run a physical cable between the primary inverter and any additional inverters on site. Now, our wireless RS485 meter link kits come with SOKA antennas that are suitable for around 25 to 30 meters line of sight. This distance meets the requirements of many sites, but where you have a greater distance to overcome, we offer high gain directional antennas. If the site has a smart meter more than 25 meters away from the inverter, make sure you buy a pair of these high gain antennas. They're outdoor rated, but the converters aren't, so keep that in mind when you're planning your installation. We recommend for best results that you don't ever extend the antenna cabling between the converters and the directional high gain antennas. But you're more than welcome to extend the RS485 cable. Extending the antenna cabling can result in data transmission issues, problems, but if you extend the RS485 cable, you're not going to have any problems. Now, one of the questions we get asked most about is distance. Now, as I've already touched on, you can expect 25 meters comfortably with the stock standard antennas, or up to 500 meters, even a kilometer with the high gain antennas. If you put the antennas in a metal box, like a meter box or inside a shed, and you're not going to get anywhere near that. Metal essentially reflects the Wi-Fi signal back and can potentially just prevent the signal from getting past at all. Now, the antennas need to be mounted outside of any metal enclosures. So if there's a dirty big shed sitting between the first antenna and the second antenna, it's not going to work. In that scenario, we recommend mounting the antennas on top of a pole on the roof of the house and the shed so there are no obstructions. Other obstructions that may impact distance are trees and vegetation, even heavy rain. As a rule of thumb, when we say line of sight, we really do mean the antennas have to see each other without anything in between. Now, the converters require power via an external power supply. They have a wide voltage range of 5 volt to 36 volt DC power supply input. So if you've already got a 12 volt or 24 volt power supply lying around, you're right to use those. If not, we offer DIN rail mount power supplies and also simple GPIO plug packs. You just need to make sure there's a power point at either end. Let us know what you need and we can help. Now, the wireless RS485 meter link kits we offer are pre-programmed and pre-paired for me personally. One converter says meter and the other converter says inverter to make it clear which one goes at what end. We do this to make it easier for you guys on site and to avoid any time wasting. Now, we also do this to avoid having to do Wi-Fi programming on site, which under the watchful eye of maybe the retired engineer could be quite frustrating. Typically, you will not need to change any of the programming on site. We do that for you. That's part of the service. And when you need additional support, we're available on the phone to take your call during business hours, so happy to help. But we prefer that you don't call us from site. We prefer that you call us beforehand when you're placing your order, so we can go over everything you need to know before you get on site and can make sure you have the smoothest installation possible for a fast and trouble-free install. So thank you, everyone. That's me. So back to you, Sebastian or Gareth.
Thanks, Andrew, for sharing with us those information. I just want to add a bit with what supply partners showed there with their solution. So we are also trying to find a solution so that, let's say, if you have inverter banks which are quite far to each other, to be able to do, let's say, Wi-Fi communication. So we are doing currently some tests, and hopefully what we can say that few sites are going well with the setup. So for example, if you look at the picture here, you can see Fronius inverter 1 and Fronius inverter number 2. So if you think about it, maybe it's 2 inverter banks, and what we are trying to achieve is making those inverter banks to talk wirelessly. So we're doing some tests, and few sites are going well. So we're going to keep people updated about this, let's say, those trials, for example. Thanks again, guys, for attending the webinar. If you have any questions, please, we're going to hang around for a few more minutes, so please go to the question segment and please ask any question if you have some. So Aaron asked if we can have the presentation. Yes, of course, we'll surely send the presentation to you guys. Thanks for the feedback, Rod. Question from Kevin. So neutral on the single phase, a reference neutral, or does it need? No, it needs to be a full size neutral there. The reference neutral is basically on our 63 amp three-phase meter. Here's another question. Can the simulation software show extra solar being added into the system as well as batteries? So I guess this question is, okay, we had this feedback in some of our training. So at the moment it's not planned, but I will give this feedback to Fronius International, and for sure we'll try to have something like that. So is the record audio presentation also available? Yes, we're gonna make that available. Do we get CPD points? Yes, I think you get 30 CPD points. In regards to multimeters, can we set up different tariff for each meter? Smart meter to monitor on peak and the first meter to monitor off peak. If it is a dedicated load, I think we can. I need to double check this one. I know that you can do different tariff on 1 meter, so the one which is at feeding point. If you want a specific one, I need to check on SolarWeb if you can select it. Varvaris, please get in touch with me and I will find that for you. Just send an email to the marketing person and we can share our contact details. So this question again, if you wish to monitor off-peak as well as normal, do you need the consumption meter in the off-peak line? So on peak and off-peak, what we can do is, for example, on the Fronius Solar Web Portal, you can choose at what time you have your on-peak and at what time you have your off-peak. Then you can get the dollar value there. So you can set up saying, okay, from this time to this time, you get charged X amount, and from this time and this time, you get charged the other amount. But to know how much energy you're using at those particular time, you don't need to do that. You can basically extract an Excel sheet, for example, and you will be able to say, okay, from 10 to 12, that's how much energy I use. From 12 to in the morning, for example, how much energy you use. Paul asked a question, can units consume overnight for certain time segment? Not sure if I got this question right. Can I see unit consume overnight for certain time segment? Yeah, you can see how much your system has been using overnight, for example. Just need to make sure you have the night mode on and that you have a Fronius Smart Meter activated. If you have a separate supply meter for off-peak, you can read it without a second meter. So if you have a separate supply meter, then you will see that. So it depends if you have this dedicated load. So if you have a separate hard connection to this particular load, if you have, then you will need to install another meter just to monitor that if you want. If it is one line coming in and going through, let's say 1 meter, and then if it comes in and then it's separated into 2 different meters, for sure you will need to use 2 smart meters, if that answers the question. Paul Gibson asks in kilowatt hours. Kilowatt hours, you will need to look on the daily view. So yeah, the daily view, if you want to look at kilowatt hour value. One question about the Primo hybrid. In regard to the Primo hybrid, I highly recommend come to All in Energy. You will be able to see the unit there, but also we can give you some updates, and also we're gonna have people from Fronius International. So it's gonna be a good time, I would say, to catch up and see what's going on. The product has been delayed up to next year, so. Unfortunately, we've seen some quality issues. So as usual, with our inspection and testing, we always put the unit in harsh conditions. So we were not too happy about the results. So that's why we're postponing the release of the unit to next year. How can a Fronius export limit be set up without internet access? So this one is really simple. What you will need to do is you don't need to set up the monitoring. You can bypass this process, and then you go to the IP address and just set up export limit. So you don't need to have internet connection on site to be able to have export limit there.
You just do it through the Wi-Fi hotspot.
Yeah. So you connect with the inverter Wi-Fi hotspot. Then after that, you open the app, you have two wizards. So you have technician wizard and solar web wizard. So you just need to go to technician wizard. Removing inverter and smart meter to another location, setting it, then returning it unit to site.
Yeah, you can do that.
Yeah, you can do it if you want. I'm not sure. Data manager box. So can I buy just the plastic enclosure and power supply for a data manager box? Not really. So basically the data manager box hardware wise and the data manager card is two different things. When I said it's just a card in a box, it was just the expression there. So yeah, you will need to buy a data manager box with its power supply. So we have a specific item code for that. And what happened is with those situation when I said, hey, installers want to provide a separate service where they monitor consumption over a few months, they can take this box after using it on site, let's say number one, then they offer the same service to another site where they just install another Fronius smart meter and the data manager box. So this box, so how we are planning to use this is, or what we are encouraging installers is install a Fronius smart meter on the site, install a data manager box, monitor the system for few months. Then when the customer is ready, remove the box, put your solar in, and your meter is already there. The meter is already installed. You just connect it with the inverter. Then go to the next side, repeat the same thing again.
We can just return to Don's question before about removing the inverter and smart meter to another location, setting it up. One of the things that would make me nervous about doing that, Don, would be that when you set up the smart meter in the inverter's interface, you're confirming that the inverter can see the smart meter, and that means that all your wiring is correct. So if you were to do it on another location and then take it to the customer's property and set it all up, you're not going through that sort of verification step, which checks that the communication between the two of them is all working well. So in theory, yes, but in practice, I'd say it's maybe a little risky.
So maybe in this situation, what you will need to do is check all your wiring again and activate the meter again, just to confirm.
Which kind of defeats the purpose. What max distance is allowed?
I think is it possible to okay, so there's another question. Is it possible to see, for example, units consumed between say 1 a.m. You can see how much kilowatt that you use, for example, and then you go to the daily view, you will see how much energy you use. So what is the max distance allowance that we can connect an inverter to a smart meter via S485? So basically it's 300 meters. So there's a question with the for supply partners with Wi-Fi extenders from supply partners. Can you use the data manager as a power source like you use the lockout antenna for generators? I haven't looked at the spec. Actually, I think it's a question for us. I haven't looked at the spec. I need to double check this one. But
Hey, can I jump in there?
Mark can get in touch with us for this one, or yeah, I will say Mark, just get in touch. I will double check for you. No, I'm not 100% sure for this one.
Sebastian, I will say,
ask a question. Any plans on releasing a 4G dongle for monitoring like solar analytics? We won't release a 4G dongle, but what we have to offer is you can buy a specific dongle. I think that Telstra sells. and then you can connect that via an adapter. So this adapter is basically a DC-DC converter. You connect this DC-DC converter to our USB port inside the unit, and then on the other end you connect your dongle, and then the job is done. So we have something like that throughout. Just get in touch with me. I can send you some information or links of where to get this converter, for example.
And just on that, said, is the reason that you use the DC to DC converter because there's not enough current out of the normal USB output on the inverter to run that dongle?
Yes, on some units, this particular dongle needs, I think, around 750 milliamps to run, and some of our units are limited software-wise to provide this. So that's why we can't. So it's limited with the current side of things.
And just to be clear on that, that's a dongle, not like the normal dongles that you stick in your into your laptop and it provides internet just to that laptop. This is a dongle that will create its own Wi-Fi hotspot.
Yeah.
And connect it through the 3G or 4G network.
Yeah. So for the dongle, I highly recommend that you guys get in touch also with us. We have like a list, or like the actual model that we tested on site, and but yeah, it's working fine. So that's why the one that I would recommend.
Yeah, you can do it from the PowerPoint too. Stuart's saying you can run those dongles from the PowerPoint.
Yeah, but the thing is, what we're trying to achieve here is, if you have it connected inside the unit, then the customer will need to remove the cover of the inverter. So basically, that's where it's clean. You know that no one will come and play and switch stuff off, for example. So that's why we found this. We try to find this solution. All right, so I can see you say that you don't want them inside, so you don't want the dongle inside the inverter. Yeah, that's also, there's some situation like that, but still we have these options for you, so you can have the dongle, let's say, inside or out. What's a bit, I would say, a challenge for us is our Fronius product. So anything that we release needs to be compatible, let's say, on the international level, and making sure that everyone can use this dongle is a bit tricky. But definitely we told international about this, and that's the challenge that they have, is to make sure that this can work, let's say, everywhere. I hope I'm gonna see you at All Energy this year. Don't forget to bring my beer, yeah. I think that's pretty much it, guys. My apologies for all the coughing. I think it's not the best week for me after a few weeks of traveling. So I think I caught something. But yeah, thanks again for attending the webinar. So the marketing part of things, the department will take care of that. So you guys gonna have all the information emailed to you later on. Thanks again, guys.